Okay, so I want to walk you through an example of how to compute a one-way ANOVA. As a sample problem here, imagine that a group of researchers is interested in looking at the effectiveness of different types of therapy on depression. So they have a group of 15 participants. They're going to randomly assign them to one of three conditions. So there's going to be a psychoanalytic therapy condition, a cognitive behavioral therapy condition, or what we call CBT, and a placebo condition. So then after 8 weeks, the researchers assess the number of depressive symptoms that each participant experiences. And the question we're asking here is, did therapy have an effect on depressive symptoms? And so we're going to conduct a one-way ANOVA. And then here's some sample data. This is the data I'll be using in the example when I'm working it out by hand. Feel free to copy this down. As far as the steps we're going to go through here, so what do we need to do? Okay, we're going to have each of our three groups, and within each of those three groups, we need to first calculate means and variances. And when we do the variance, we have to use that n-1 formula. Once we have all that information, we can go ahead and calculate MS within. And all we're going to do there is average those variances that we computed in the previous step for each of the groups. And then we need to do our mean squares between. We're going to compute the variance of those sample means, again using the n-1 formula. So we got to calculate the grand mean. We got to get our mean deviations, square them, add them up, and divide by n-1. Then we're going to multiply that estimated variance of sample means by the size of the sample that we're using. We can then go ahead and calculate the F ratio, and we'll check our calculated F ratio against our critical value to determine whether or not that result is statistically significant. So here I think are all the formulas that we're going to be using. So we need to get our within sums of squares. Remember, for the within sums of squares, we need to get the variances within each group. So I've included that formula here, but really assuming you either know how to compute a variance, which you should at this point, or you're given them in a problem, which we're not here. We're going to calculate them from the ground up. But this would be the formula you'd use if you didn't have them like we do here. And then the only formula you really need that's new here for an ANOVA is this formula for MS within. We then need our between group sums of squares. So this is our formula here where we get the variance of a sampling distribution of means, where again we're going to calculate the grand mean, subtract it from each of our individual sample means, square those differences, add them up, and divide by the number of groups we have -1. And to get our MS between, we're simply going to take that value that we get in that first step here with the grand mean and that variance we compute and multiply it by n, where n is the size of the groups that we are using here. So in today's example, we have 15 people total, but they're assigned to 3 separate groups. So that's 5 people within each group. So our n, as you'll see, will be 5. And once we have that, we can go ahead and compute the F ratio. So we're going to divide our mean squares between by our mean squares within. We can evaluate that F ratio against a critical value of F, and to do that, we're going to get our, we're going to need our degrees of freedom to get our critical value. So we'll calculate our numerator degrees of freedom and our denominator degrees of freedom. Okay, so now we're going to go ahead and get started calculating our means and variances within each group. For reference here, I'll write down the formula for the variance. We already know how to do the mean. So our estimated population variance, we'll repeat this for each group, but it will be the sum of the squared mean deviations divided by n-1. So we can go ahead and calculate our mean. Sum of these x-scores is 30, and the mean for the placebo group is 6. 30 divided by 5 will give us 6. And now we need to go ahead and calculate our variance. So we're going to take the mean and subtract it from each of the scores. Now we need those squared mean deviations. And now we need to get the sum of the squared mean deviations. Okay, so we have this piece. Now we need to get the estimated population variance for this placebo group. So that's going to be 34 divided by 5 minus 1, and here is 5. 5 minus 1 is 4. And so our estimated population variance for the placebo group is 8.5. So we're going to repeat this process for each of the individual groups here. So for the CBT and psychoanalytic groups. Okay, so now we can go ahead and compute our MS within. We can do between first and within. It doesn't matter what order you do them in. We'll do within because it's easier. Remember here, we just need to get the average of those variances that we computed in the previous step, the averages of the variance for the different groups. So for the placebo group, the variance was 8.5. For the CBT group, the variance was 2.5. And for the placebo group, the variance was 2. And so there were 3 total. So the sum is 13 divided by 3 gives us an MS within of 4.33. Okay, and we can now go ahead and get our MS between. So the first thing we need to do is calculate that variance of a distribution of means here based on our 3 sample means relative to the grand mean. So those means, again, were for the placebo group, it was 6. For the cognitive behavioral therapy group, it was 3. And for the psychoanalytic group, the mean was 4. So we go ahead and we compute the grand mean. The sum here is 13. 13 divided by 3 gives us 4.33. And then just like before, we subtract the grand mean from the means. We're computing a variance, right? And then we need to square those differences. We need the sum of those squared mean deviations. And now we just need to divide that number by n minus 1. Again, n here is 3 because we have 3 groups. And now to get our ms between, we need to multiply that by n, but again, where n is the size of our samples. So in this case, we had samples of 5. That's our ms between. Okay, so we can go ahead and put together our F ratio. So we found ms between. So we have to put ms between over ms within. So we found ms between to equal 11.67. We found ms within to equal 4.33. So our calculated F ratio ends up being equal to approximately 2.69. So of course we need to evaluate this against a critical value of F. To do that, we have to get to use our table. We need our degrees of freedom. So our degrees of freedom, sorry for the sloppy writing here, but for our degrees of freedom between groups, it is the number of groups that we have minus 1. So we had so for our between groups degrees of freedom, we had 3 groups minus 1 gives us 2 associated with our between groups estimate of variance. Our degrees of freedom within is the sum of the degrees of freedom that we have within each of those groups. So when we estimated those variances separately within each of the groups, we divided by n minus 1. So we take the n minus 1 for group 1, in this case the placebo group, plus n minus 1 for group 2, which in this case was the CBT group, and we take n minus 1 for group 3, which in this case was the psychoanalytic group. So the degrees of freedom within is equal to 4 plus 4 plus 4 equals 12. And if you use this information and you look it up in the table, you should find that the F critical value is equal to 3.89. So this was our calculated value, and this is our critical value. So if we're trying to evaluate whether our result is statistically significant, we need to compare these two values, and if our calculated value exceeds our critical value, we'd have a significant result, but of course we don't. 2.69 is less than 3.89. So it would appear, based on these data, that the type of therapy that people underwent did not have an influence on number of depressive symptoms.